So this is the first worked problem for Thermo Charette number 2. Now this is going to have to do with Module C and property tables. Now our problem is 1.8, problem statement is 1.8 meters cubed rigid tank contains steam at 220 degrees Celsius. 1/3 of the volume is in liquid phase and the rest is in the vapor form. You have 3 deliverables. You have to determine A, the pressure of the steam, B, the quality of the saturated mixture, and C, the density of the mixture. So, first we have A. Determine the pressure of the steam. Now, because our T, we know our T equals 220 degrees Celsius, and it is a saturated liquid vapor mixture, we can go to our table A4, and we can look at 220 degrees Celsius. Our saturated pressure is going to equal 2,319.6 kilopascals. 2,319.6 kPa. We can round that to 2,320 kPa for the sake of calculations. Now, that was part A. Now that we have that, we can move on to part B. Now, part B is a little bit more tricky. We're going to determine the quality of the saturated mixture. Now, the equation we would use for this is typically specific volume equals the specific volume for the liquid plus the quality times the specific volume of the gas minus the specific volume of the liquid. We don't have everything we need, so we need to figure out our specific. We're going to go towards our total mass. We're going to figure out the masses of the mixture first. Now our total mass is going to equal mass of the liquid plus the mass of the gas. Now first, we're going to calculate the mass of the saturated liquid. That's going to equal the total volume of the saturated liquid divided by the specific volume of the saturated liquid. Now we can calculate what the total volume of the saturated liquid is because in our problem statement, 1/3 of the volume is in the liquid phase. And we know that the volume of the rigid tank is 1.8 meters cubed. So our volume for the liquid is going to equal 1/3 of our total volume V. Our total volume V is 1.8 meters cubed. So our volume for the saturated liquid is going to be 1/3 of 1.8 meters cubed. And that's going to equal 0.6 meters cubed. Now that we have the total volume, we need the specific volume. But because we have our saturated water temperature table, we can go up here, we can look that at 220 degrees Celsius, the specific volume for a saturated liquid is going to be 0.001190 meter cubed over kilograms. So our specific volume equals 0.001190 meters cubed over kilograms. So finally, our mass for saturated liquid is going to equal 0.6 second. It's going to equal 0.6 over 0.001190. So our mass for our saturated liquid is going to equal 504.2 kilograms. Now we're going to repeat this process for our gas. So our mass of our saturated vapor is going to equal the volume of the saturated vapor over the specific volume of the saturated vapor. Since we know 1/3 of the total volume is a saturated liquid, goes to stands that 2/3 of the total volume, the rest, is going to be saturated vapor. So our saturated vapor is going to be 2/3 of 1.8 meters cubed. That's going to equal 1.2 meters cubed. Now we need to find our specific volume for our vapor. And if we go up to our saturated water table, we see that at 220 degrees, the specific volume for the saturated vapor is 0.086094. So our specific volume is going to be 0.086094 meters cubed per kilogram. Now we plug this into our equation. We get 1.2 over 0.086094. So the mass for saturated vapor is going to equal 13.94 kilograms. Now we have the total mass of the rigid container. That's going to equal the mass for saturated liquid plus the mass of our saturated vapor to get 518.1 kilograms. Now that we have this, we can determine the quality. Quality of our mixture is going to equal the mass of the gas, of the vapor, over the total mass of the system. That's going to equal 13.94 over 518.1 kilograms. And this comes out to 0.0269. We can use this equation because quality is essentially how far along the vapor dome is the mixture, how much of the substance has turned to vapor, and as we can see, very little of it has. Now we can go to part C. We can go to part C. Part C is going to ask us to calculate the density of the mixture. Now we can use the equation, our density equals 1 over the specific volume of the mixture. We can say this because specific volume equals the volume divided by the mass, so we can just shortcut it there. Now to calculate the average specific volume of the mixture, we're going to use the equation, the average specific volume equals the specific volume of our liquid plus the quality times the difference between our specific volume of the gas and the specific volume of the liquid. Now we have all these, we calculated them earlier, so we can just go and plug them in. And our average specific volume is going to be the specific volume of the liquid, which is 0.00190, plus the quality, which is 0.0269, times the difference between our saturated vapor and saturated liquid, which is going to be 0.086094 minus 0.00190. If we calculate that, our specific volume, our average specific volume is going to be 0.00347 meters cubed per kilogram. Now we just plug that into our equation. Density is going to equal 1 over this average specific volume, which is 0.00347. So our density is going to be 287.8 kilograms per meter cubed. That is our final answer for part C.